Hello everyone, welcome to DC Minds. In this video, we are going to learn about stack data structure. Let's understand it from a real life example. Suppose we are given a plate like this and we want to arrange this plate so that it will occupy less space. So what we can do is we can take all this plate and put one plate on top of another. So we can do like this. So one plate, then next plate we'll take and we'll put on top of other. Similarly, we'll take third plate and we'll place on top of the second plate. Then we'll take this fourth plate and we'll put on the top of this third plate. So this is kind of organizing this plate in some way. So this is called stack of plate. So here what we have done is we have organized that plate in the form of stack. Okay, and now suppose if you want to use the plate, then what we'll do, we'll use the plate on the top, this fourth plate. So we'll use this fourth plate for our purpose. And next time again, if we want to use, what we'll do, we will use this third plate. So what is happening here is this this fourth plate was added at the last but what we are doing is we are using at the first. Okay, so this behavior of this stack is called LIFO. That is nothing but last in first out. What last in first out means, the last added element, the last added plate here is used first. So stack is called last in first out because whatever is there in the last, that is getting used first, and adding on the top of this stack is called push operation in programming, and taking from this stack is called pop operation in programming. Let's see the push operation. So in C programming or in C++, so initially we have given a data like this and we have to push into stack, basically add into a stack. So initially we have a stack like this, and that is nothing but a box, and we want to add data into this. So first what we'll do, we'll add this 5. So initially we have this stack and this stack is empty, nothing is there, so this top -1 indicates it is empty. So let's add this 5 into the stack. So after adding, the stack will become like this and top will become 0 because we are incrementing the value. And why it start from 0? Because the stack is implemented with the help of array, and array always start from 0, means it indexing start from 0. That's why it is 0. Next we'll take this 2 and add to the stack. So top will become 1. Next we'll add 15, then 13, and the stack will become full at this time, and top will become 3. Okay, so this operation is called push operation. Now if we try adding one more time in this stack, suppose we want to add one more item, we'll say push another item. What will happen is that this stack is already full, we cannot push another item. So what will happen, error, this is a error, adding one more item in the stack which is already full is a error. So what we should do, before adding any item, we should check for full, whether a stack is full or not. Okay, so let's see now pop operation. So now initially we have given a stack like this and it is now filled with data, and next we want to remove this 13 from this stack. So what will happen, we'll take out this 13 and this stack will become like this. Now top will become 2 because we have removed this 3. Then similarly we'll keep removing 15, then we'll remove 2, then we'll remove 5, and finally stack will become empty, and this empty stack is denoted by top, which value is -1. Okay, so this is called pop operation. Now at this point, if you see, the stack is empty, and if we say remove one more time, we'll say pop from this stack. What will happen? This is a error situation because the stack is already empty, and if you say pop one more time, what it should give you some error. So we should always check whether the stack is empty or not before removing any item from the stack. So we should check for empty of the stack. So if you observe it here, what is happening here? We are adding the element on one on top of other. So if you see, 13 is added at the last here. 13 was added at the last, but whenever we want to remove, we are removing this 13 at the beginning. So last added element here is being removed at the beginning. So this is because of this nature we call a stack as LIFO, that is last in first out data structure. Now let's see pseudocode for this push and pop operation. Okay, so we have empty stack, and this empty stack can be represented in programming like this. Okay, so initially we'll say a stack of 4, that is nothing but array of 4, and top equal to -1 to indicate this is empty stack. Okay, next, for to add the element, we'll write code like this. Basically we'll say stack of top plus plus. Top plus 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 will be incremented. What it does means, first increment the value of this top, that is from -1 to 1, sorry, -1 to 0, and then assign the value at this 0 location. So this is 0 location, this is 1 location, this is 2 location, this is 3 location, third location. So it will go to this 0th location, and stack will become like this, and top is this, because array will always start from 0. Okay, so similarly we'll keep on adding element like this. Finally this stack is full, and if we want to add one more item in this stack, what will happen? It should give a error. So before adding, we should check for condition for full. So we can check condition like this. Before adding element into this stack, top plus 1 equal to 4, because size of the stack is 4 and top is 3, and we should add 1 to indicate that the stack is full, because array start from 0. This means it will become 0 to 3. That's why we are adding 1 here. So this is pseudo code for stack push operation. Let's see pop operation. So now we have stack like this, and we want to remove this 13. So for this we'll write code like this. So this, what it will do is, it will use the value of top, and then it will decrement. So basically this is post decrement, and this is pre increment. So pre means first increment, and post means first decrement here. Sorry, not first decrement, decrement after use here. Post means decrement after use. So here what will happen? Stack of 3 will become 13, means 13 will be taken out, and then stack will become like this, because value of top will become 2. So first use, then decrement, post means. Okay, so like this we'll keep on removing element, and finally the top will become -1, because we have removed all the element from the stack, and -1 indicates it is empty. Now a stack is empty. If we want to remove one more time, if we say pop means try removing one more time, at this time this is a error, because the stack is already empty. So we should check for condition saying that if top equal to -1. So -1 indicates stack is empty. Now let's see code for this push and is full function. So we know we have to add element like this, stack of plus plus equal to 5. to whatever we want to add. So now the function to add this item into the stack will look like this. What it does is initially we have a stack of size 4 and top minus 1, which indicates it is empty. Now we have a function, say this push, and it takes a parameter as item. This is item parameter. So whenever we call this function, we'll pass whatever we want to push into a stack. So if we want to add 5 into the stack, what we'll say, we'll say push of 5. So in this case, what will happen, it will increment the value of top, means minus 1 will become 0, and it will add this item, it will assign this item. So this is similar to this. Okay, so now this is function to add the item into the stack. Now we have to check whether the stack is full or not before adding into the stack. So what we can do is we can write a function for each full, whether stack is full or not, like this. So what we'll do, we'll say top plus 1 equal to 4 if this is a boolean return type for this function. Boolean means it is true or false. It will either return true or false, these two values, true or false. So in this case, what will happen, it will check for this condition, and if this condition is true, this means stack is full, and then it will return true, otherwise it will return false. So in this case, at this point in time, the stack will be full, so it will return true, otherwise in other this case and this case, it will return false. Okay, so this is for is full, for checking for full, whether stack is full or not. Now this push function should always check whether a stack is full or not before adding the element into the stack, because if in this case, if we try adding one more item when a stack is full, it will give an error. So to avoid that situation, we should first check stack is full or not. So this push function can be rewritten as like this. So we have the same function push, and it takes parameter as item, and it will check here is full equal to true. So what will happen, we'll check for true, and whenever we call this function, what will it will come here, and it will check for this condition. If this condition is true, it will return true. So when this condition is true, means it will return, if this function is returning true, means this value. So what will happen, true equal to true means both are same, it will become true. So what will happen, it will print stack is full, and it will return directly from here. Otherwise, in this scenario, these cases, stack is not full. So what will happen, this condition will become false, and it will come here, and what will happen, it will increase the value of this top, and will add the value. So this is the function for push, the code for push function. Now let's see code for pop and is empty function. So now the pop function look like this. it it has a return type void, and it does not takes any parameter. So whenever we call this pop function, what we'll do, we have declared an variable called item, and in this item we are storing the value which is at the top. So we know this is top minus minus means post decrement, means first use the value and then decrement it. So what will happen, value of top is 3. So what will happen, item of top. So item of top means this stack of top will be 3. Top will be 3, and the stack of 3 will become 13. So in this case, 13 will be stored in this item, and then we'll say popped item is 13. So in this case, there is a mistake over here, I have done it. So I shall remove this part. Okay, so this is the pop function. So what will happen, it will print this value over here, popped item is 13. Next, so this is the function to remove item from the stack. Now next will be we have to write a function that will check whether a stack is empty or not. So we know a stack will be empty when top is -1. So we'll check for this condition top equal to minus, and then we'll return whether it is true or false. So this is return type is bool and return two values, true or false. So we know that we should always check for empty condition before removing any item from the stack. We should check for whether the stack is empty or not to avoid the error situation, because in this case situation if you see the stack is already empty, and if we say pop one more time, then what will happen, it will give an error. So we should check for empty. So this void pop function means basically this pop function can be written as like this. So what we'll do, we'll check for this empty. So what will happen, we'll first call this function, what, and this function will return whether it is true or false. So if it is returning true, what will happen, it will condition will become true and it will print stack is empty. Otherwise what will happen, it will come to line this line and it will take the item from this stack. It will say stack of top minus minus, and it will print the item. Okay, so now let's see the entire program. So this was the void function with checking whether, basically pop function with checking whether the stack is empty or not, then only removing the item. Now let's see entire code. So this is the entire code for stack operation, and the various operations are checking for full, then checking for adding the item, then checking for empty, then removing the item, and this is the main function which will call these operation like push function, pop function, and perform the various activity. So now initially the stack is empty and size is 4. So stack look like this, and next what will happen, we will call this push function so with value 5. So what will happen when we call this push function, this call will come over here. So it will come to this push function, and this item will have value 5, and it will check for this condition. So in this condition it will call this is full. So it will control will go to here is full, and at this time it will check for whether the stack is empty, sorry, stack is full or not. So what will happen, top plus 1 means initially the top is minus. So what will happen, it will say -1 plus 1, that will become 0, and 0 equal to 4. This is false means this condition is false now. So what will happen, it will return false, and now this value, this function is returning false. So this condition will become false, because false equal to true means false. So what will happen, it will come over here, and value of this top will get incremented first because it is pre-increment, and then this item is having 5 from here, it will be stored into the stack. So stack will look like this. So top will be incremented by 1, and value will be stored in the stack. So similarly it will be 2 will be stored, and 15 will be stored, then 13 will be stored like this. Now stack is full. Now if you try pushing item, one more item, in this case when it comes here the item will have 25, and it will check for this condition is full, and when it calls this is full, it will come over here and it will check for top plus 1 equal to 4. Now the value of top is 3, so 3 plus 1, that will be 4, 4 equal to 4, yes it is true. So it will return true, and it will come again over here, and this is returning true means true equal to true, this condition is becoming true. So it will come over here and it will print stack is full, then it will return directly from here. So at this line of code will return this, basically display this message saying stack is full, because our stack is already full. Next we'll see pop operation. So Now we have a stack like this, and now when we call this pop function, what will happen? It will first call this and it will check for empty condition. So basically it will check whether a stack is empty or not. So now a stack, this is not empty because it is having some value, and this top will be 3. So this condition will become false, so means it will return this false. And now this is returning false, so false equal to true, this is false, this condition is also becoming false. So what will happen? It will come over here and it will take the value from the stack. So stack of top is 3. So 3 will be, item will have 13 because at 3 item is having, sorry, stack is having 13. So 13 item value will be 13, and it will print popped item is percentage d. Percentage d will be replaced with this item value. At this time it will be 13, and then value of top will be decremented, so it will become 2. So now the stack will become like this. It will remove this item 13 item 13, and then value of top will be decremented. Like that it will, we can, when this line of code will remove 15, then 2, then 5. So we have removed 15, then we'll remove 2, and you can see this value of top is getting decremented, and finally we'll remove 5, and then stack will become empty. Now if you see, the stack has become empty because there were four element we have added, and we have removed 4 element, so the stack is empty. Now if we say pop one more time, what will happen? It will come over here, and again it will check for this empty. So when it comes over here for checking for empty, it will check for top equal to -1, and now the stack is empty, means top equal to -1. So this condition is becoming true. Then what will happen? We'll remove this, sorry, it will return true from here, and then it will come over here, and this function is returning true, means this condition is becoming true. So it will come over here and it will print stack is empty and directly return from here. So this is how this program is working. So this is the full program for stack and the working behavior. Next is, the same program can be written in this way. So if you observe here, we can just declare a variables of which name is size, and we can write uh, a stack like this, means we can declare a stack like this, just give the size. And then push function can be rewritten like this. Instead of writing a separate function that will check for stack is full or not, just we can directly check for this condition, top plus 1 equal to size, and size value is 4. And instead of doing top plus plus, we can first increment the value by 1 and then use it. Similarly, pop function can be rewritten like this. So top checking for empty was top equal to -1, so we can directly check for this condition here, and then after using, instead of saying top minus minus, we can use the value and then decrement the value. Okay, so this is the function for, okay. And there is a mistake over here as well, so let me correct it. This is the, so this is another way of writing the stack operation. Okay, so these are the use cases of stack. So we can use stack for expression evaluation. What this means is that, suppose you have expression like this 2 plus 3. So if we want to evaluate this expression in C programming or other programming language, we can use stack to perform this evaluation operation. Means this 2 plus 3 into 4. Basically this 3 into 4 has to happen first, and then the addition has to. So this expression evaluation will be, can be achieved in programming language using stack data structure. Similarly, we have to check for parenthesis matching in an expression. So suppose you have expression like this 2 plus 3 and open parenthesis close parenthesis minus 9 open parenthesis 9 uh, divided by 3. So in this case there is a missing parenthesis, close parenthesis missing here. So to check whether the parentheses are matching, means balance or not, we can use a stack data structure. Okay, similarly we can use stack to perform uh, expression conversion. So basically what do I mean by this is, you have expression like this, say 2 plus 3. So this is infix expression. Basically 2, there will be first value and then operation that we want to perform, and then next value. So this is infix expression. If you can convert this expression into prefix expression like this, so first will be operation that we want to perform and then the values. So in programming language these operation is required, means we have to convert expression one expression to another expression in some situation. So for that purpose also we can use stack data structure. Similarly we can use a stack data structure for memory management basically for call stack. So whenever you use a function, what will happen, the function will have some data, means some memory is required. So that memory will can be allocated on the stack. So it will be used managed using stack. Similarly we can use this stack in backtracking problem. This is the one algorithm that is used to find some solution to a problem. Okay, so now let's see one more real time use case of stack. So now this is a Word document, and in this I will draw just some shape. So first I am drawing a rectangle, then I am drawing a circle. Okay, so I have drawn a circle, and then I am drawing an arrow. So now what I have done, first I have drawn rectangle, then circle. This is not exact circle but kind of circle, and then an arrow. So now in this document there is a option to undo. So we can undo the things that we have done it. So now whenever I do this operation like undo it, what will happen? This arrow will be gone. So if you observe here, the last operation that was done is been removed first. So arrow was added at the last, but when we undo it, it is been undone first. So if you observe here, what is having last added item is basically getting removed first. So similarly if I do undo one more time, then this circle will be gone. So last added items are getting removed first. So this means this kind of feature, if you want to implement some in some places in some application, we can use the stack data structure. So this is the one real-time use case of a stack data structure. Okay, so always remember stack is LIFO, that is last in first out. So last added item will be removed first. So that's all about stack. If you like this video, please subscribe to my channel. If you have any query, please comment it. If you feel this video will be useful for your friends and colleagues, please share with them.